I've got the part mostly set up on the mill now. I put shorter studs in and lowered the planer jack to support the clamps. That's another nice thing about the planer jack is you get infinite adjustment and quite a range of adjustment. So those are working good. Now I need to, this is the face that's going to get machined. And I need to get it parallel to the table as well. Now it's warped in like this, if you remember. So this edge and the far edge stick out the furthest. Now the plate's about 1/2 inch thick. If I can, I'd like to leave some of that plate on the table for support, instead of it just the table being here where my finger is, and same with the other end and this hanging outboard. This is machined nice and flat now, and I'd like to keep it on the table if I can. So I'm gonna use just a 3/8 piece of high-speed steel as a guide to space this out 3/8 of an inch, which will leave an 1/8 of an inch touching here. And because of the 1/8 inch warp, there'll be about 1/4 in the middle that'll be resting on the table, and I think that should be good. Also, when I machine it away, I'm gonna take an 1/8 or just a bit more, so there'll still be the face mill will still be 1/4 of an inch from the table, so I don't have to worry about hitting the table with it. So anyways, I'll just get that set up on the table using the high-speed steel here. And this will be a bit by feel. It doesn't have to be perfect because the surface will be trued up. Oh yeah, that feels pretty flush. That one's actually the other way. It's going to come out a little bit. It's hard, a little hard feeling through rubber gloves, but you know what? I go back a bit. Oh yeah, I think that feels pretty good. Oh, I think it's a little. Anyways, I think that's pretty good. I'll just check the other side again. Yeah, that probably just a touch. Oh yeah, that's good. Now we can tighten them down. And there really shouldn't be any sponginess now, because this plate that I'm pushing on goes straight down to the table and it's machined surface. So if I'm feeling anything, it's just a little bit of bend in the clamps. And the thread flanks touching each other on the planer jacks as they load up. I think that's good. Watch the bottom readout. That's for the knee, and when I tighten the clamps, it'll likely move. That's how I found out there was wear in the knee right after I installed the readouts. A little bit of swarf. You can kind of see the warp here. I may have actually could have gone less. I could have went less than an 1/8 there, but you can see the width here and how it decreases in the middle and comes back out. That's the warp coming out of it. Turned out pretty good. You can see where the two cuts are, but like here you can't feel anything. Here you can just barely feel. So locking the knee seems to work. I think I have a pretty flat surface. I was thinking about taking a finishing pass, but I think that turned out good enough. I'll just leave it the way it is. So I was curious to see just how much of a mismatch there was between the two cuts. And the easiest way to check that is, because the part's large enough, is just use my height gauge. So I've zeroed it, zeroed it on this cut, and I'll just swing the indicator down onto the other. Now it seems worse in the middle. I don't know if you can see that or not, but it's 1 thou in the middle. When you get out to the edge, it's virtually nothing, maybe a 1/10 or 2. So 1 thou is, for what this is doing, that's good enough. Now the setups, Not too much work, at least for the clamps, because it's essentially being clamped in the same position, just reversed, but spun around, I guess you'd say. Now I need to dial this surface parallel to the table travel, and that's where the overarm comes in handy. There's a way of mounting a dial indicator stand too. So I got it set up in 0, and I'll just run the table back and forth and tap it around until I get it to run 0. Good enough. It's 0 at both ends. I always get deflection in the middle of these on this mill, and I believe the reason is that the table also has wear on the dovetail, so it doesn't travel in a perfectly straight line, and so this surface won't be perfectly flat. It's probably low about 2.5 thou, and I think what happens is the combination of when this was machined, it was facing the other way. In order for this to be 2.5 thou low, oh wait a minute, what is it, low or high? Yeah, it's low. When this is set up and machined, because the table has some wear, I believe that the table moves that way as it gets towards the middle of its travel, and it has the effect of causing the cutter to go in deeper, so it causes this shape. Then, so now it's already got that bit of shape to it. Then you flip the thing over and you put it on this side. Now, when you run it down the table, not only does this have that shape, but the table moves in and out. So you get an exaggeration. So I'm getting about 5 thou of deflection from here, say 0, 5 thou that way, back to 0. The reality is that this is likely 2.5 thou low from the ends, which again, for this job is fine. So I'm gonna say that's good enough and tighten it down. Now, we'll have a look at the cutter I'm gonna use. This is a really large end mill I got off eBay. It's a 2-inch, and it's got 3 flutes, which is unusual. At least to me it's unusual. Maybe in this size that's more common, but that's the largest end mill I've ever bought. And I got the end mill holder off eBay as well. They just fit. I have just enough clearance here, and it's I'll have to see how it works. The part is now held pretty rigidly to the table. This is You know, I must have about 9 or 10 inches of overhang, but it's all pretty heavy, thick stuff. So I'll just have to try it and see. The only thing I don't like about this setup, because of the problems with the knee having wear, in order to machine these surfaces, I actually have to move it with the knee. And when I machine each side, you know, the table and everything is way off to one side, so the knee wants to rock over that way. And then when I move this down to this way, the knee's going to want to rock over that way. So I may end up with a situation where the two surfaces here are not parallel to the two surfaces at the other side. I can picture them being kind of like that, but it's highly exaggerated, but it gives you the idea. I suspect if they are, it's not going to be much, maybe 4 or 5 thou from here to here. And then that's where, you know, and even if you welded it like that, it would probably be okay, because I have to come in and bore the holes out. And I've allowed about a 1/16 of an inch clearance between the bucket and the pin boss plates on either side, axial clearance. So that would probably be okay. But my welding fixtures here are going to actually space the pin boss plates. So really what I need to do is just make sure that the maximum distance between this face and the other face isn't greater than 28 7/8, I believe it was, I made the welding fixtures to. They were machined quite accurately to length on the lathe using the digital readouts. You'll see that in the video I posted about making the welding fixtures. So they'll hold them straight and parallel, and then of course that's only for tacking. And then once you start laying in heavy weld beads, all bets are off on how straight things are going to stay. So so I think even though the knee rocks a bit, this will work okay. I just wanted to show one of the problems you can run into with this spreadsheet that I made for calculating speeds and feeds. It's not a problem so much, just something you need to be aware of, and it stems from the fact that the feeds that you select are for the X and Y travel of the table, but the vertical travel of the knee, which I need to use to machine this part, is never the same as the X and Y travel. And on this mill, it is 2/5. So the knee moves up or down at 2/5 the feed rate that the table moves in the X and Y direction. So I have this 2-inch end mill with 3 flutes. So I'll go through how I would normally calculate it. They tell us here, I'm saying this is free machining steel, so I'm going to go with about a 5 thou chip load per tooth. And I'm going to go to about the 50 to 60 surface feet per minute range. So for 2-inch, what do we have here? 57.6, that's kind of in the middle. So that's 110 RPM I need to run at. So then I go to my sheet for 3 teeth, because this is a 3 flute end mill. And I'm at 110, and I look here, there's 5 5/10 chip load, which gives me 1 13/16 inches per minute. However, because it's the knee, that's not correct, because the knee runs slower. So what you can do is say you want about a 5 thou chip load. Since the knee moves at 2/5 the speed of the listed feed rate, you need to multiply the chip load per tooth by 5/2. So just go 5 and 5, divide 5 by 2, that's 2.5. So essentially you need to be using an apparent chip load per tooth of 12.5 thou per tooth. So you go down the 110 column and well, let's just say we'll go 10 9/10, and that gives us 3 39/64. So by choosing 3 39/64, when we're machining with the knee, we'll actually get close to our 5 thou per tooth chip load. It's a complication, but if you're aware of it, you can work around it. I know the Cincinnati mills are the same. They're not 2/5. There's some other ratio, but I would imagine that all milling machines like this have a slower feed on the knee. So it's just something to be aware of if you want to actually use the correct chip load. So I started machining the plate to take the pin boss, or the frame rather, to take the pin boss plates. And you can see I've done this side. It's mostly done. There's a finishing cut left on this side. But I ran into a problem. The plates don't actually come down quite far enough. They're a little bit shy where they should be in order to allow a weld along here. What happens, I probably lost a bit more when I machined the bottom. To be honest, when I drew this thing up, I can't remember if I allowed for warping in the bottom. I probably didn't. So I took an 1/8 off, so that shortened that distance up from there to there by an 1/8. So anyways, what I did is I kind of picked the middle ground, and I ended up leaving about a 1/16 on here. So there's a slight gap, which isn't the end of the world when you're welding anyways. And then these pieces here, I'd left about a 1/4 inch machining allowance on here, this step up. My plan was that would be machined off to a nice flat surface, and then it would touch up against that plate and be welded. I'm going to need some of this now to make up the missing distance. I won't be machining a 1/4 inch away. What I'll be doing is just machining it till it cleans up. I'll probably clamp both in the vise and do them at the same time so I can get them the same. And I'll just take light passes till I get it to clean up, and that'll give me the maximum amount of extra to make up some of that missing distance. What'll happen then is this will still sit a little. Well, I guess we can look at this drawing here. This piece will sit a bit lower in the end. It won't be quite as bad as I originally thought it was going to be, by using some of the allowance on here and leaving a bit of a gap. It won't be quite as bad, but the net result will be that the hole will shift upwards relative to this piece. However, it's probably end up being only an 1/8 or 3/16, and there's a fair amount of material around the hole, so I think it should be fine. And that'll be those holes will be corrected when I do the final boring with the milling head turned on its side. I'm glad I was going to machine these first. I'm glad I did the frame first, otherwise I would have machined all that allowance away. Now I can keep that allowance, and I can also position the holes to give me the extra distance between here and the hole I'll need to make up for that shortened plate. So now I'm just about to start the other side, and it's a bit of a awkward setup. I don't really have a good way of measuring 28 7/8 other than with a tape measure. So what I did was I measured it, and as it was welded, it was 29.5, and it was like exactly 29.5 on the tape measure. It was right on the line. So it means I have to remove 312.5 thou per side. I've so far roughed 275 off the one side I just showed, and then what I'm going to do, I'm going to actually machine the side right now that I'm just picking up to 312.5. I'm going to zero the readout, and I'm going to travel down the 28 7/8 plus the diameter of the end mill, and that should get me 28 7/8 in theory. It may not be exact because the knee has some motion in it, some slop, but I think it'll be closer than I could measure with a tape measure, and I think that'll work out. So I'm just gonna pick up this side and then machine it, and then I'll go down and do the other side. With all the overhang on the end mill, even though it's a big, thick 2-inch end mill, it does vibrate. I got some chatter. But again, it doesn't matter that much. The surface is going to be covered with a weld, so. is actually a good opportunity to point out something I learned shortly after I got this mill about where to apply coolant to a horizontal end mill. And when you're using it in a vertical mill, you always just kind of put it up near the top or right into the cut, and gravity just pulls it down into where the cutting is happening. When it's horizontal, you want to place it near the end of the end mill, and the flutes will actually draw the coolant across the end mill. You can see how it's sort of falling off evenly across the whole length of the end mill. If you put it up near the top of the end mill, you can see you don't really get any at the end. Anyways, just something that's different than from the vertical. Well, that's her. In theory, that should be 28 7/8. In reality, I'm not sure. But I'll see if I can find out. Well, this is a case where theory definitely bumps into reality and reality wins. I thought I'd just check with the welding fixtures I made. Now I face these to length on my lathe, and I use the digital readout on the lathe on the carriage travel to set the length. So these should be very accurate. They should be within a thou or two of the length that I machine them. Now I've set this up with a 1, 2, 3 block and touched them, so these two surfaces are flush. Now in theory, these two, this and this, are supposed to be the same distance apart from the other end, and you can definitely feel a bump. Oops, you can definitely feel a bump. And I checked it with a depth mic, and it's 30 to 32 thou roughly. So this did not work, my idea of using the readout on the table and the diameter of the end mill. And it makes me wonder if I'm not sure, because oh, well, that could partially be from the rocking of the knee, I guess. Yeah, that could partially be from the knee leaning over. This would pull away, and that might make it longer. I'm not sure if it would have went that much or not. The other thing is that the end mill may not be exactly 2 inches in diameter. And being 3 flutes, it's awfully hard to measure. So I think what I'll do is I'll just go back and I'll take another 15 or 16, maybe a little bit more. I'd rather the welding fixtures be a little bit longer than the space on the frame. So I might take 20 thou a side off, and then for sure there'll be a little bit of play there. Okay, so I did another machining step on the ends here, and I didn't bother to show it because it's just more of the same. And then I put the welding fixture on and measured it, and the welding fixture is now about 24 thou longer than the distance between this face and the opposite face, which is good. The welding fixture will space them properly. There'll be a little bit of play here. We can tap it around, and if we absolutely want to get it centered before we weld it, which I don't think really matters, but we could just put a 12 thou shim in one end and tack the other, then pull the shims out and tack this end. So should work good. And that wraps up the pre-machine on the frame. I still have to machine the pin boss plates, pre-machine those, and that'll likely happen tomorrow. Thanks.